Hello and welcome to Vitosh Academy. My name is Vitosh and today I'll be presenting some part of a chapter of a very interesting book called Math for Programmers. And it is about drawing with 3D and 2D vectors in linear algebra. Pretty much I'm taking the code from GitHub of the author of the book and I have edited it a bit so it is possible to get it into one quick YouTube video. Bear with me and then let me know whether it makes sense to continue with linear algebra or whether I should stay with Python and VBA videos mainly. Okay, so let's start. So we have the Jupyter notebook opened with the code, and as you see I'm importing quite a lot of stuff from other places, pretty much other projects from the chapter, mainly vector naming here, which is this one, vector drawing, and then I have something else imported somewhere like draw 3D, which is this one. So let's quickly take a look at what we are importing. Vectors, some fancy or not so fancy functions for vectors, for which I'm going only to use this one, translate. And from drawing 3D, I am importing one really interesting called draw 3D, which is this one, which actually gets an object origin and then axis, width, and that's it, and it pretty much draws it. And then we have vector drawing, and this is the thing that actually draws the picture. So stay for the next couple of minutes with me and you'll see it in action. Okay, so Shift and Enter pressing from vector drawing import start, and these are some of the input vectors that I have created myself. I'll just put them and then I'll override them with the next one. Let's see, Control Alt and minus. How can I split this one? I cannot split, but okay, let's continue. I mean, there is a quick way to split a cell actually. Okay, Control Shift and minus. Yes, okay. So these are the input vectors. This is how they look like. If you press B, then yes, you get something like 6, 4, some minuses. Doesn't look like anything familiar. But if you draw it with points, for example, just with points, it would look like this. And if you add like lines between these points as a polygon, it would look like a nice dino. Let's take a look. So this is what we would be working with today, and then I'll show you some of my drawings as well. So that's why I call it input vectors. Let's continue from draw 3D, import a few things. And now the first interesting part is pretty much we are going to have a function called polygon segments 3D, color blue, leave it blue, which would return us an object segment 3D, which was, I think, here, segment 3D, or somewhere else, doesn't matter, in the Jupyter notebook that we are having. And what we would be making is the interesting thing, input 3D. We will be putting xy and adding a 1 for each xy in the input vector, and then we would present this picture here as 3D. Let's take a look quickly. Ta-da! This is what happened. So this picture here is already from 2D into 3D. And if we put, for example, 2, then this one, the third dimension, the one that if you are writing on your desk, if you take a look, it would be like a spike towards you. It has moved from 1 to 2. We can move, for example, 21, and you see the Z dimension just became 21. So this is a really quick and interesting way to make from 2D into 3D Just this zip here actually tells us, okay, I take the x and y from this picture, I add just some number, roughly speaking here, and I am printing the segments, and it's actually a 3D in a way, I would say. Yeah, okay, interesting and simple 3D, but it is a 3D. I mean, you see it's in 3 dimensions, so that's how it looks. Let's continue with the next one. Shift and enter. And this one is just a function about linear combination that returns the scaling of the scalars and the vectors. In Bulgarian, we'll call it probably scalar, but in English, I think the correct pronunciation is scalar. So enabling the linear combination function and then multiply matrix vector. We get the matrix, we get the vector, and we return linear combination of the vector and the matrix. And now the interesting part, for which actually I'm doing this video, is the identity matrix here, which in the code was called magic matrix, also this way in the book, because it's really interesting. What is on the identity matrix? The idea of the identity matrix is that whenever you multiply a matrix towards the identity matrix, for example, any 3 by 3 matrix by this identity matrix would return exactly the same 3D matrix. But in this case, we would have a bit more fun. I'll show you later what we can do with this identity matrix. Here, we just enabled it, and we'll put the translated. So pretty much as far as it's the identity matrix, the translated would be exactly the same as this one. And if we draw it, there wouldn't be a difference between the translated one and the input one, fortunately or not. So now is the time to start making stuff. For example, what we can do is if we change this one into 2 of the identity matrix and we press shift and enter a few times again, then we saw that the translating one, which is in cover C3, which if we go to here, we will see that C3 is actually red. So if we go back here, we will see, okay, the color is red. So the translated one just moved a bit on top, like on the second level of Z. We can put, for example, 22 here. It would be interesting. Just moved way up to the 22nd of Z. What we can do, we can play a bit further. We can see what will happen if we double this one. It's the Y or Y direction. And we saw something interesting. In the Y direction, it shrank a bit. And if we also do the same with the X, it also shrank. Now the interesting part is, let's have this one translated into a 2D back. So how do we translate 3D to 2D? Well, if it is like this, a linear 3D or a plane 3D, a 3D that can be put in a plane, it would be kind of easy. So pretty much we are saying we just want XY for XYZ, we are eliminating the Z. Pretty much the same that we did here a bit above, but we say, okay, for the Z we get 1. So let's see how it would look like. I'm curious as well. So now let's draw the points and the polygons. And this is how it looks like. We have the original one, and then we have the translated one. The blue one is the translated one. Or no, it's the other way around. Yes, it is the other way around because it's 5. Yes, this is ours, and the original one is the red one is the bigger. Yeah. What we can do, something else, is why this matrix was called pretty much magic in the book. was that we can move it around. For example, we can move it by 3. Here, just let's take a look. But let's fix back the others. So it's 1, 1, 1, and just move by 3. You see here, you already feel that it's going to be moved into the Y direction up. And let's take a look here. And you see that it has been moved by 3 up. And this just was achieved by changing the magic matrix. I mean, we can also put it down if we feel like it. Yeah. So the blue one is the original and the red one is going down. Something else to do with the magic number here, with the magic matrix, we can put it a bit to the right just by adding 3, and I'll add 2 here. So what I'm expecting is 2 up and 3 to the right. So translate it. Yeah, exactly. You see the blue one, and we have 3 up and 2 to the right, which actually works. Yeah, so far this is what I wanted to show. Additionally, I was thinking about showing a few more stuff with some vectors and some pictures that I have created myself. Okay. So this is a simple picture of a mountain, and what we can do with a dino, of course we can do with a mountain as well. Pretty much this is how it works. And you see the original one in blue, and then the one that is moved away going to red. Yeah, the dino was funnier, but the idea is that we can do it with other things. And now I saw also one of the exercises in the book. They were like pretty much saying draw 100 dinos, so in one plot. So I'm going to put it like 100 drawings, and I'm going to use almost its code like 99%, but I'll try to explain it. Okay, at least this is what I'm going to think about. So I don't remember, what was it, 15 times x, 15 times y, or y for x in range minus 5, 5, for y in range minus 5, 5. Let's print this one just to see what we are getting. Okay, so what we are getting here are what I'm seeing like 100 positions. So we start with minus 75, 75, minus 75, and then we finish with 60, 60. So the idea is that we're going to use something called translation. And this translation is a function that is here. I mean, I have it, but I can copy it as well, so it's visible for everyone. And what this translation does, it says, okay, I'm getting the translation and I'm getting the vectors. So let's see what it will translate. For example, I'm having my input, this one, the simple one, that looks like this. And I'll try to translate it with 3 by 3. So let's see how it would look like. Translate 3 by 3 input vector. And just to see how it would look like, I'll copy it here. So it just edits 3 and 3 into everything. So yeah, this is how it goes and how the translate works. But this is not what we are doing. We are doing 100 drawings into one picture. So I explained how the translations work. So we're giving different coordinates for all the 100 here. So I'm going to call it drawings, and it's gonna be polygon, which is a class declared in one of the fancy other editors that we are using. Polygon, translate, and we are going to translate t and input vectors. And then we are going to say, okay, the color, the original one was blue, and I'm going to put a fill red. Okay, for t in translations. Pretty much, as I said, it would make this kind of translation like here for each one of our 100. Why are they 100? Because we have range here and range here. So it would return around 100, exactly 100 actually. So then we have the easy thing draw, which we have seen a bit above. So draw, drawings, and then start with grid, none, axis, none, origin, none. Okay, and now let's code this one. Now it returns something which actually looks like it. What we can do is we can play a bit with the numbers. Let's see what will happen. I know what will happen. It will not be pretty. Yes, it's this one. But we can play a bit more with it right here. Then it is actually pretty. What we can do further is we can re-enable the vector, the input vector back, the fancy one with the dino. And if we go here, it will be dino as well. I'm just putting it out. Yeah, these are the 100 dinos, and we can play a bit. For example, with the numbers, we can play it 12 to 10. Let's see how it will look like. And we would have all the dinos. We can change the colors, red, blue, or red, green. Because St. Patrick's is close, I think. Yeah. And we have the 100 dinos. So, I hope you have enjoyed the video as much as I did. Pretty much in the description below there will be some code for discounts if you're interested in buying the book, for example. It's a nice one. And enjoy the rest of your day, and please let me know whether I should make more videos about linear algebra and whether you're interested in the subject. So that's all. Bye.